Today we're beginning Unit 2. Unit 2 is the Introduction to Logic and Proof. We're going to specifically spend time looking at inductive and deductive reasoning. Before we start, I have a warm-up activity. In the past, students have completed this activity within their groups. This year, obviously that can't happen. So after I read the following statements, I'm just going to ask that you pause your video, answer the question to yourself, and then come back to the video in which I'll go over my answer. So the following statement says, Part A, I scored below a 60% on the past 3 tests. The next test I take will also be below a 60%. Part B says, if I scored below a 60% on a test, then I earned an F. I earned an F on my last test, therefore I scored below a 60%. And I'm asking you whether or not both statements are always true. So press pause, think about each one individually, so think about Part A and Part B, and what your answer would be. So my answer for Part A would be not true, or not always true. So this might be a pattern, but it's not a definite conclusion. So it could happen that you score below a 60 more often, but occasionally you would probably score over a 60. There's no certain conclusion that you have to earn that grade. For Part B, my answer would be always true. This is a statement based on facts. So if you score a 60 and a 60 is an F, then that is the end of the statement. There's no other questions. That's based on facts. Hopefully you had similar answers to what I did here, but again, this is just a warm-up leading us into inductive and deductive reasoning. As you can assume, one of these is going to be inductive and one of them is deductive. So a conjecture, we talk a lot about these. A conjecture is an educated guess based on given information. A conjecture. A conjecture is an educated guess based on given information. Before I go over examples of conjectures, let's talk about what inductive and deductive reasoning is. Starting with inductive reasoning. Inductive reasoning uses several examples to make a conjecture. And when we're talking about examples, we're talking about patterns that are going to be given to us. Using inductive reasoning to make a conjecture does not always create a true statement. That's important. You might make a conjecture that is not true, in which case we'll talk about counterexamples later in the notes. Over here I highlighted a pattern because a pattern is one of the biggest indicators that you are dealing with inductive reasoning. If we look at the example I provided, we have a pattern between numbers. We have a list 0, 1, 3, 6, 10, 15. When I look at this, I see the first time I'm adding 1. 0 plus 1 is 1. Then I'm adding 2. 1 plus 2 is 3. Then I'm adding 3. 3 plus 3 is 6. Add 4. 6 plus 4 is 10. Add 5. 10 plus 5 is 15. So based on this pattern, we can assume, we don't know for sure, but we're going to assume that the next number is going to be 15 plus 6, which is going to be 21. And then we're going to assume that we're adding 7. When we add 7 to 21, the next number would be 28. This is an example of inductive reasoning because we're using a given pattern that we're assuming, so we can assume this is the pattern, but we're using that to find our last 2 numbers. We don't know for sure that those are our last 2 numbers, but That's what we used, or that's what we came up with using our inductive reasoning. If we compare this to deductive reasoning, deductive reasoning uses facts or definitions to reach a logical conclusion or conjecture. So deductive reasoning is concrete. You have facts that are given to you that cannot change. Using deductive reasoning will always create a true statement. So up here, I'm going to highlight facts or definitions. And if we take a moment and look at the example, this example comes from our last unit. We have an angle, and our statement says that ray CD bisects angle FCA. So we know that a bisector divides an angle into two congruent angles. So if CD, this line here, is bisecting this entire angle, FCA, then we can conclude we have two congruent angles. So we just created two congruent angles. And if I come up with a conjecture or a conclusion, I can say that angle FCD is congruent to angle ACD, these two angles here, by the definition of an angle bisector. So this is always true. This can't change. This is a concrete fact in geometry, that if you have a bisector, you have two congruent angles. So to just sum up what we talked about in each of these sections, inductive reasoning states or alludes to the fact that your conclusion is probable, but it might not be true. If you're dealing with deductive reasoning, this means that your conclusion is certain. There is no question about your conclusion if you're dealing with deductive reasoning. So I'm going to take a moment and show a 1-minute clip of a video that explains inductive and deductive reasoning using other examples other than math.
You start from something general and draw a specific conclusion when it comes to deduction, whereas the reverse is valid for induction, with you starting with specific premises and drawing a general conclusion. Here's a simple example for deduction. 1. I start with something general and say that all my family members use money, and 2. I say something more specific, that John is a member of my family. From these two premises, I draw a specific conclusion, that John uses money. Let's move on to an induction example with me making the following specific statements. 1. My mother uses money. 2. My father uses money. 3. My brother uses money. 4. My sister uses money. From these specific premises, I draw the general conclusion that all my relatives use money, and the more examples of relatives who use money I think of, the more probable I consider my conclusion. Please understand that with deduction, your conclusion is certain if your premises are true. However, when it comes to induction, your conclusion is only probable if the premises are true, and the more premises there are, the more probable the conclusion becomes.
For the first example, we need to look at our 3 situations, make a conjecture, and then determine whether or not we are using inductive or deductive reasoning. So when you make a conjecture, you're making a conclusion based on what you're given. So if you're given a pattern, use that pattern to create a conclusion. If you're given definition or facts, Use those definition or facts to make your conclusion. Looking at the first one. So the first one states that Mario took 3 shots on goal and he scored 3 goals. So my conjecture says the next shot Mario takes will be a goal. I am just assuming that. So when I read my situation, he took 3 shots, he got 3 goals. So I'm just assuming that the next one, based on a pattern, is that he will score another goal. My thought process behind this would be considered inductive reasoning because I'm using a pattern to come to my conclusion or to come to my conjecture. So inductive reasoning would be the reason, and I just typed it's a pattern. It might not happen. There's a good chance it will, but there's also a good chance that it won't. There's no way for us to know. For the second situation, this states that it says, I am taller than George. George is taller than Lisa. So after reading that, we have 3 people. We have myself, George, and we have Lisa. The conclusion I'm going to make is that of the 3 of us, so of the 3 people, George must be the shortest. All right, that's just using what facts are given to me. I'm taller than George. George is shorter than Lisa. So if I make a list, George has to be the shortest. I used deductive reasoning for this. This is based on facts. So we know the general description of their heights. We know who's the shortest. That cannot change. That's based on given info. So deductive reasoning. And for the third situation, states that my 2 friends got their driver's license when they turned 16. I turn 16 next month. So my conclusion is going to state that I am probably going to get my driver's license next month. Okay, if I turn 16 next month based on the pattern of my friends, then I'm probably going to get my license again because I'm turning 16. This is using inductive reasoning. It's using a pattern based on what my friends did. But there's so many other factors that go into this. So you might fail your driving test. There might be weather, something like that. So this pattern does not stand to be concrete in any way. Therefore, this would be inductive reasoning. For the next example, this says below are some situations. Circle all situations that use deductive reasoning. So recall that deductive reasoning is based on facts and it has a concrete conclusion. All right, looking at the first block right here. This is a geometry statement. It says line AB and line FG do not intersect. Therefore, AB is parallel to FG. So if we think back to Unit 1, this one might be a little difficult to remember, but we went over this type of line called skew lines, and skew lines are lines that do not intersect because they are on different planes. And when I explained this to you, I explained it as the floor of the classroom and then the ceiling of the classroom. So you could have a line drawn any way on the ceiling, and you could have a line drawn any which direction on the floor, but those two lines will never meet. So they're not necessarily parallel, they're skew lines. This one is not considered deductive reasoning because our conclusion is not true. So I'm not going to leave that one circled. Let's look at the next one. The next one is based on patterns. So we can assume what the next image is going to be, or the next pile or block of circles, but we don't know exactly what it's going to be. We only know what the pattern is. So we're assuming, and that is inductive reasoning. So we're not going to leave that one circled either. For the next one, if you are 48 inches tall, you can ride the new ride at Great America. You rode the new ride, so you were taller than 48 inches. That's a fact. So you have to be 48 inches tall to ride the ride. If you got on the ride, then you have to be at least that tall. So that is based on facts. That is a certain conclusion or a concrete conclusion. So we're going to leave that one, and we're going to indicate that that one is deductive reasoning. Next, we're looking at a statement that says a regular hexagon has a side length of 3 inches. The sum of all side lengths is 18. So I need to give you a little background on this one. A regular hexagon has all equal sides. That's what the word regular means. And a hexagon has 6 sides. So this is telling you that you have a figure with 6 equal sides. So based on the extra info that I just gave you, if every side of that regular hexagon is 3 inches and you have 6 sides, then 6 times 3 is 18, and that is true. That is based on facts. That can never be different. If you are adding up all of the sides, 3 plus 3 plus 3 plus 3 plus 3, well, 3 6 times is going to equal 18. So that one is, in fact, deductive reasoning. Next, we're looking at the statement that says students go to school Monday through Friday. Today is Monday, so all students are in school. Now, I know there's so many other factors that you could consider with a statement like this, but you have to go based on what is written, what the situation is. So what's given to you at hand. This says students go to school Monday through Friday. Therefore, if today is Monday, students are in school. So based on what is given to you, this would be true. This would always be true based on that info. Therefore, we're going to say that that is deductive reasoning. Now, of course, if that mentions that there's holidays or summer or whatever, then that changes the whole situation. But this is just a basic exercise. This one does not mention any of that, so that is going to remain as deductive reasoning. And the last section. So this last section, this should be a quick, easy one to see. This is a pattern. Patterns automatically indicate that you're using inductive reasoning, so that would not be deductive. We don't want to leave that one highlighted. So of the 6 situations, we have 3 of them highlighted for deductive reasoning. Now, these are pretty basic deductive reasoning ones. Most of the ones you're going to see on your homework or on quizzes will be specific to our geometry class. All right, not all conjectures turn out to be true. You should test your conjecture multiple times. You can prove that a conjecture is false by finding one counterexample. You only have to find one, and it instantly makes your conjecture false. So a counterexample is exactly what it sounds like. It's an example that shows a conjecture is incorrect. If we look at the examples, number 1 says the difference of two positive numbers is always positive. Well, most of the time, you probably can assume that that's going to be true, because if you had something such as 6 minus 3, that's equal to 3. So the difference is still a positive number. That's true. However, what if we switch these two numbers? If we switch these two numbers and we do 3 minus 6, 3 being a positive number, 6 being a positive number, and we find the difference between them, the difference is going to be negative 3. So this right here, this makes for a counterexample, which makes this false. So here's your counterexample for the first one. You only have to find one counterexample to make an entire statement false. Number 2 says if the name of a month starts with the letter J, then it's a summer month. This is also false because right away you should all think of the month January. And January is your counterexample because it is a winter month. And the last one says when you multiply a number by 2, the product is greater than the original number. Be careful with problems like this. This just says it's greater than, but if we do something such as 2 times 0, 2 times 0 is 0. That's not greater than the original number. The original number was 0, and your output is 0, which is just equal to the original number. So this right here is your counterexample. It's probably the only counterexample you could quickly think of. May even be the only counterexample ever, but all you need is one of them to prove that the statement is false. This is it for today's notes. There's an extra note sheet and practice attached on my website if you would like to check that out. But also make sure you complete your Go Formative. Your Go Formative has specific questions related to this lesson. Please email me if you have any questions.